Okay guys, so today we're going to do a lab dealing with the LeChatlier principle. And this would be the principle that deals with when we add a stress to an equilibrium. So let's check out this reaction here. I know it's kind of hard to see right now. This is the best I got. So this cobalt hexahydrate ion with a 2+ charge reacts with chloride ions to produce this cobalt chloride ion and water molecules. Now, remember about equilibria and how they're different than all those other reactions we've talked about this year. We got this backwards arrow, which means that while this forward reaction is going on, this reverse reaction is also going on. This is this dynamic process. So those cobalt chloride ions are also reacting with water molecules, go back and form chloride ions in this cobalt hexahydrate ion. Now, what else do you notice about this that I just added? Because I wanted to get it in the chemical equation. I wrote that word heat on the left side of this reaction to indicate that this is an endothermic reaction. So that forward reaction would be using heat, and I guess that means that the reverse reaction would be producing heat. Okay, now I'm gonna do 6 things here. I'm gonna add 6 stresses. Now when I say add a stress to an equilibrium, it just means like trying to change something that we have here. Now, if we look at this test tube on the left, I made this one start out favoring reactants. So I could tell you that right here in this test tube, we have a favoring of the reactants because it has this pinkish color, which would be the color of these ions. Now in this test tube on the right, I have this starting out favoring the products. Now these products here, it kind of lost some of the color here, but these will have this bluish tint. So if the equilibrium is favoring reactants, it'll look pink. And if the equilibrium is favoring the products, it'll look blue. Okay, now let's add our first stress. Okay, a little assistant, come here.
What?
Bring me that first container. So what I'm going to do now to both of these test tubes is I'm going to add some HCl. Now remember, HCl is made up of H+ ions and Cl- ions. Now the thing we're really interested in here are those chloride ions. So I want you to think for a moment where the chlorine ions are in this equilibrium. Okay, so let's take and add extra chlorines to both of these test tubes. Okay, now this one is the only one that's kind of hard to see, so the pink one actually changed to blue, and the blue one stayed blue. So what we're trying to do here is find out what's the final color, and it's always going to be the same for both of these. So it's either staying pink or turning blue, and it looked like this one was turning blue or staying blue. Okay, so there was our first little stress. So we added chlorine ions as a part of HCl, and we saw the test tube that was pink turned blue, and the one that was the blue stayed blue. Okay, next. Now I'm going to add water to this. Okay, assistant, bring me my water tube.
This one?
Okay, now let's take water and let's add water. Now look where water is in the balanced equation. It's on the product side right now. Let's go ahead and add water to the pink one and see what happens. Okay, looks like it stayed pink. So let's see what happens when we add water to the blue tube. Oh, check that out. When you add water, it turns pink, and then when you add water to the pink tube, it stays pink.
Something's not right.
Something's right, I think.
Oh.
Okay, assistant.
Second one?
I need the third bottle. Okay, now, this one's a little weird. We're not always adding things to these tubes. Sometimes we can do things to remove substances from this equilibria too. So here, let's start out with a pink and a blue again. And here I have some silver nitrate. Now silver nitrate is going to react with these Cl- ions to form a precipitate, silver chloride. So essentially when I add silver nitrate, I'm not adding something. What I'm really doing now is I'm removing Cl- ions. So now let's see what happens when we remove Cl- ions. So let's add some of the silver nitrate to the pink tube first. And we see all that white silver nitrate, silver chloride precipitate forming. But the color still stays pink here. Okay, now let's add the silver nitrate to the blue tube. Again, we see that precipitate forming. Oh! Huh. It looks like when I remove Cl, the pink one stayed pink, but the blue one turned pink.
Yeah, you have to work.
Huh, what's going on here? Okay, a few more experiments going on here. Okay, assistant, I need the powder with the funnel, please.
Powder.
The powder with the funnel, please. Okay, now, before I start this one, I'm going to do something a little weird here. I'm going to put some boiling water on the side, and I'm going to put a pink and blue tube in the boiling water, and hopefully by the time I finish with the little demo here, we're going to see a change there as well. So over here on the side again, I just put a blue and a pink in the boiling water, so we can see what's going to happen now. Okay, for our fourth experiment here, I have some calcium chloride solid. Remember, calcium chloride is just made up of calcium and chlorine. So I don't care about the calcium so much, but I have that chloride ion right here. So what I'm doing again essentially is adding chloride ions to these two equilibrium. So let's first add it to the pink. Oh, and now let's add it to the blue. Okay, so what do we see going on here is it looks like the pink one turned blue and the blue one stayed blue. Okay, interesting. So the pink one, when we added chlorine, turned blue and the blue one stayed blue. Okay, assistant, I need my acetone. That's the one with the red cap.
Red cap, this one?
The red cap one, yep. Okay, good job. Okay, so acetone is another one that's going to act a little differently than we're used to here. So what acetone's going to do, when we add acetone in here, it's going to be removing water. So again, when we add acetone, acetone is going to essentially remove water from this. Okay, so let's add acetone to the pink one. Oh, we already see stuff happening. Shake it up a little bit. It looks like the pink one is turning blue. And it looks like we might be able to guess it, but when we add acetone to the blue tube, it stays blue. So acetone to the pink tube turns blue, and the acetone to the blue tube stays blue. Okay, now last thing here. Over here, we added heat to the mixture. So I added heat by putting these two tubes in boiling water. And I don't know if we're going to see this one in time, but I can see it here. It looks like the blue tube is staying blue, and I don't know if you can really see it too well, but it looks like the pink tube is starting to turn blue. So when I add heat in the form of just putting these tubes, these equilibria, in this boiling water here, the blue one is staying blue, and the pink one is turning blue. So now, after performing all of this, our goal is to now try and think about what happens when we add a stress to an equilibrium. So what happens when we add a stress, which could also mean removing something, to an equilibrium? The thing could be something from the balanced equation, it could be removing something from the balanced equation, or it could be even some sort of heat. Okay, I hope you can use this lab to start thinking about the LeChatlier principle. Again, bonus points if you convince people that it's pronounced LeChatlier. And then that's what we always call it outside of our realm. But try and think about the effects of this LeChatlier principle on equilibria, and then we will talk next class about this.